What's up YouTube, this is Print Practical. Today we're taking a look at my sim drifting setup. I have a Logitech G27 wheel, pedals, and shifter combo that I bought around 5 years ago. And then in order to make this a VR experience, I'm using a Oculus Quest 2. Yes, this is a very budget-oriented setup, but one of my biggest complaints is that there is no emergency brake accessory that goes along with this set. If you've ever seen any sim racing or drifting online, you'll see that most of these creators have these elaborate cockpit setups, which have the steering wheel, shifters, e-brakes all mounted in a very similar location that they would be in a real car to give you that realistic feeling. My Logitech setup is a simple clamp onto the desk, the wheelbase, the shifter, they just clamp onto the table. So let's hop into actually doing some design work to see if we can come up with a solution for an emergency brake. First, let's talk about the requirements. The first requirement for this project is that the emergency brake needs to mount to my desk, similar to my steering wheel and my shifter. Since this is being mounted on my desk, it needs to be low profile, similar to the shifter. If you see any of the other sim setups, they have these long e-brakes that you pull on, but in this case, we need to have something that matches the set, which means we need a low profile e-brake. And finally, I need to make this a USB device. I need the computer to recognize this as a USB gamepad and that it has one variable input that I can later map into an e-brake functionality in whatever racing game I'm playing, specifically Assetto Corsa for my first game. Okay, enough blabber, let's hit the drawing board. I'm not a mechanical engineer, but let me talk you through what I think I'm gonna do. So I have a rectangular piece of plastic here, which I'm considering as the base. This will be clamped to the table. And then my idea is I'm gonna have this slide that my e-brake handle is gonna ride on. And that slide is going to go in between two rails. And then I'm going to 3D print a spring that is going to be pushed up against the backstop. So you're going to pull the e-brake down and then the spring should throw it back up. You know, eventually I'll have to put in a piece here to stop the e-brake from overshooting, or maybe I'll design that as part of the lid. But either way, I think this is what I'm going to initially go with. And then I'm going to leave some space at the top or on the side or something to put a Raspberry Pi, probably a Pico, which is the microcontroller version of a Raspberry Pi. And this is what I'm going to attempt. All right, so it's been a few hours and this is my very early prototype. As you can see, I have this slide that I'm going to mount an e-brake handle right here. I have a 3D printed spring and the rails. We really wanted to test the concept of this rail system. And as you can see, it actually works pretty well. Back to the drawing board, here's our current design. One problem is that the slide can go out past the rails, so we need to design some sort of stop here. Something else we need to do is translate this motion into something that the Raspberry Pi Pico can understand. For this next revision, I am going to add 3 different features. One, I am going to add a removable stop that I can put in there. After I put the e-brake slide in against the spring, this will contain the slide within the rails. 2, I'm going to add a piece to the slide that is going to hold the potentiometer over one of the rails. And then I am going to put a gear on the end of the potentiometer. I'm going to put a gear rack on the right rail so that whenever this slides back and forward, it's going to spin the pot. Hopefully it works. Let's just draw it up and print it out and see what happens. A little bit of design work, a little bit of printing, and this is what I have for the second revision. The extra resistance of spinning the potentiometer is making it feel a little less snappy than I'd like it to feel, so I'm going to increase the strength of this spring. That feels so much better. I got so excited by that last prototype that I went ahead and I designed a e-brake handle that fits into the slide. But one problem is I made the screws so small that the threads did not come out that great, so it actually does not thread into the handle. So scrap that fancy 2-screw design. What I did is I made another handle with a big ass hole in the bottom of it, and a new slide with a big ass hole in it. And I have this big screw, which it's a lot easier to print big threads, and you use your big old screwdriver to screw it in. And boom, there is a sample e-brake handle and slide. So this is what we got so far. All right, I moved over to my setup. I have my e-brake mounted next to my shifter, just using some wood clamps for now. And I wanted to see how it felt moving from my shifter to the e-brake, feeling the e-brake mechanism. And I have to say, it feels okay. I think that I'm going to continue with the electronic portion next, but there are some problems. All right, so let's take a look at the e-brake mechanism. I pull on it. Now, I'm pulling on it in a special way. I'm pulling on it from the lower end, and I'm actually pushing with my thumb because I need to keep the force in the backwards direction. If I just pull on it like I feel like I should, it starts to bind, and that's because this back end of the slide is lifting up and pressing against the rail, and it's causing more friction. And I feel like, you know, I can get used to pulling back directly backwards, but it's not perfect, and you could probably break it off the table. You can see the whole rear end of the base plate lifting off the table when I pull it sometimes. Especially when you try and pull it from the top, you really have to just pull backwards to get it to feel smooth. I'm going to try and lube it up, just for fun. What happens if I lay this down, I throw some super lube on it. And I flip it over. Some super lube on this end, and slide that bad boy back in there. I don't know if super lube works on plastic. I am not a material engineer, but let's see. Well, now I can pull from the top and it slides. It's still ripping up the back of the base plate, so I'm gonna have to come up with something better. But that actually did work pretty well. It does feel good now. We'll see. I think for now, it feels good enough for me to go and experiment in the electronics department to see if I can figure out how to make this a gamepad. And then we can test the whole setup as is, and then we can go on and see if we can improve it. All right, so I have my Raspberry Pi Pico with a USB cable, and I have my potentiometer wired up to it. It took me about an hour with CircuitPython to get something up and running, but let me show you what I got. Sorry, I have a really short USB cable here, but I have the Pico plugged into my PC. I have the potentiometer here in my hand. I have Content Manager up for Assetto Corsa, which allows me to configure all my inputs, and I set my handbrake to the CircuitPython HID device, and as you can see, I'm getting input for the handbrake. Alright, this is the first test of my 3D printed emergency brake prototype. Let's try it out. been a few days, got a little distracted, birthday things, baby things, but coming back to this project, I did a little bit of CAD work last night at like 2 in the morning, threw it on the printer. This is what I came up with. All right, we're getting to the point where we're doing some final touches now. Here was the basic handle I had before. I just made some slight adjustments, put a little bit of a grip on there. Feels very good in the hand, so happy with that. Most of the modifications happen to the base. I have these holes here where I'll sink brass nuts in order to hold the newly designed lid on. The lid came out nice. One thing I did forget is that I'm going to have to cut out a slot here for the USB cable that's going to come out of the Pi. But I still have to do one more revision, so I'll add that in. I'm very impressed with the tolerances of this printer to be able to print these tiny standoffs and these little caps that press fit onto them to hold the Pi in. But, I mean, this Pi isn't coming off. This is a awesome solution that I wasn't sure if I was going to be able to print it or not, but worked out really well. And then the other main modification is this clamping system. I previously designed a headphone clamp for my desk, so this design was very inspired by this. But I used this to hang my headphones up on my desk, and I made pretty much just a smaller version of that, and 2 of them that press fit into the base. So if you've watched the video up until this point, I just want to say thanks for watching. Do me a favor, subscribe to the channel, and put a comment down below. Tell me what you think about this project. I think it turned out pretty sweet. So let's try and grab some cool clips of the final e-brake setup.